All right, let's explore how we measure potential difference. So these rules that we are establishing right now are super, 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 super important. So everything we're doing today, make sure you get and you understand and you follow, because if you deviate from these rules, our results are not going to agree. But if you're consistent with these rules, even though you and I might work the same problem two different ways, if we are both consistent with these sets of rules, we'll get the same answer. So this first set of rules that we have to go over is, how do we measure the potential difference across a power supply, a battery? So here, this says for an ideal battery in the negative to positive direction, potential increases. So what do we mean by negative to positive direction? Well, first off, I'm going to just start off drawing my circuit again. And I think we'll just reuse this same basic circuit. So we have our power supply, we have resistor 1, we have resistor 2. And we will say this power supply is a source of EMF. Remember, the negative terminal is the narrower line, the positive terminal is the wider line. When we are evaluating circuits, you personally, individually, you have to decide on the direction that you choose to evaluate. So in other words, the direction that you choose to apply Kirchhoff's law for voltage. So for me, so I can stay consistent with how I work problems. I usually like to start from the negative terminal of the battery and work my way around. And actually, that negative terminal of the battery is attached to both resistor 1 and 2. So I will just call this point A, positive terminal, point B. And here we have 3 potential loops to take, 3 potential directions to evaluate voltage. If I go from the negative terminal to the positive terminal, that's a particular path, path 1. So for path 1, notice that I am going from the negative to the positive terminal of the battery. When you're going from the negative to the positive terminal of the battery, your potential increases because the battery does work to lift charges up. So we will say the potential difference from A to B is equal to positive the EMF of the battery. Now, I said Mel, personally likes to start off from the negative terminal and go through the positive terminal in my analysis. You don't have to do that. As long as you're consistent with the rules, you and I are going to get the same results. You might choose to go from the positive terminal to the negative terminal. That might look like this, going from B to A. Let's just call this path 1 prime to distinguish it from path 1. Now, if you choose to go in that direction, what you have to know is if you're going across the battery, and so let me write this path 1 right here, 1 prime. So here we have the battery oriented like this, negative terminal on the left, positive terminal on the right. But if we choose to analyze going from positive to negative, well, that would be the potential difference from B to A. We're going from high potential to lower potential. So that means that the potential difference from B to A is equal to minus the EMF of the battery. So again, if you choose to analyze the battery from the negative terminal to the positive terminal, I'll call it a path. These are paths we are taking. When we take the path from negative to positive, we give the battery a positive EMF. If we take the path from positive to negative, the battery is a negative source of EMF. The battery will fight you.